All right, we've got a scenario here of rolling 2 dice. So we know this is an independent event. And when you're asked what's the probability that you roll a 4 and a 5, so I'm looking for the probability that I roll a 4 and a 5. And you might be asking yourself, well, what is that? Is there a difference between getting a 4-5 and a 5-4? So one way that we can think about this is going back to our sample spaces. So if I think about a grid of values, so I could get 1, 2, 3, 4, 5, or 6 on my first roll, 1, 2, 3, 4, 5, or 6. Sorry, first dice and second die. So thinking about getting a 4 or a 5, sorry, a 4 and a 5, well, that could happen in this situation or in this situation. So I've got 2 out of 36 ways that can happen. So that's like thinking about getting a 4-5 or a 5-4. So I would have 1 out of 36 plus 1 out of 36, 2 out of 36. Now the probability that I get a 4 or a 5, well, that would mean I would get a 4 and anything else, or a 5 and anything else. So if I think about this on my diagram, so the 4 column, I could get any of these options. So that would also encompass this 4. The 5 column, sorry, I'm gonna make that a bit smoother. So the 4 column, I have all 6 of these options. The 5 column, I have all 6 of these options, but I could get my 4 or 5 this direction as well. So I have all of these options. That should have included that one. And then the 5 column, I have all of these options. So what I'm really looking for is my unique options. I don't want to count them again. So I have 6 here, 6 here, another 4 that are unique here, another 4 that are unique here. So the probability of this happening is going to be 6 plus 6 plus 4 plus 4 out of my 36. 10, 20 out of 36 different ways that can happen. So if I wanted to do it with multiplication, I would think of getting a 4 and anything else. So that would be a 4 is 1 out of 6 chance. So we have 1 out of 6 times anything else would be 6 out of 6, plus a 5 in anything else, that would be 1 out of 6 times 6 out of 6. And then I have the other option that anything else happened and a 4, so plus the same thing. I would have that again, so I would end up with this 4 times. So, all right, let's say that we double that. But now I've counted these options twice because I counted both of these twice. So I have to subtract off 2 times my probability that my combinations happened because I don't want to count them again. So we would end up with 24 minus 4 is 20 out of 36.